Today's video is on integration using residues. In today's video, we are going to determine the poles and the residues of the given function. F of z is equal to z squared plus 2z by z minus 1 squared into z squared plus 4. See here, from the question, f of z is given as this is z squared plus 2z by z minus 1 whole square into z square plus 4. So first of all, we have to find the poles. So in order to find the poles, we have to equate the denominator to 0. So here, if I equate the denominator to 0, this is z minus 1 square into this is z square plus 4 is equal to 0. So if I equate z minus 1 whole square is equal to 0, are the pole values is equal to z is equal to 1 for 2 times. Therefore, z is equal to 1 is a pole of order 2 is a pole of order 2. And for next thing here is z square plus 4 to 0. So z square plus 4 can be written as, this can be written as z plus 2i into z minus 2i is equal to 0. So this is a plus b into a minus b, which is equal to a square minus b square. So if I equate z plus 2i to 0, then z is equal to minus 2i. So if I equate z minus 2i to 0, then z value is equal to plus 2i. So these are the simple poles. Clear? See, first of all, what is given? So the function f of z is given like this. So in order to find the poles, we have to equate the denominator to 0. And after equating denominator to 0, we got the pole value as z is equal to 1, which is of order 2. And here, if I expand in the form a plus b into a minus b, so this will be z value is equal to minus 2i for one time and plus 2i for one time. And these are the simple poles. See, first of all, we have to find the poles for the given following function. And next one, we have to find the residues for the corresponding poles. So first, I'm going to find the poles for z is equal to 1. For z is equal to 1, the residue at the point, residue of f of z at point z is equal to z naught is nothing but 1 by m minus 1 factorial into limit z tends to z naught d by dz power, this is m minus 1 into this is z minus z naught power m into f of z. So this is the formula, and in this, so what is m here? M is the order value, m is equal to 2 here. So m is equal to 2 and z naught value here is the pole value, that is 1. So if I substitute everything here, then I'll be getting the residue value at the point z is equal to 0. So here, residue of f of z at point z is equal to 1. At point z is equal to 1. See here, this will be 1 by m value is equal to 2. This is 2 minus 1 factorial into limit z tends to, here z naught value is equal to 1, d by dz power, this is m minus 1. So this value is 2 minus 1 into this is z minus z naught value is 1 power m. M is again 2 into f of z. So what is f of z here? So f of z is nothing but, so this is z square plus 2z by z minus 1 square into this is z square plus 4. Clear? Z square plus 4. So I can cancel these two and see, this will be 2 minus 1 factorial is nothing but 1 factorial I'm leaving. So this is limit z tends to 1 d by dz times of, so d by dz times of what remained here, that is z square plus 2z by this is z square plus 4. So I have to make a derivative for this function for one time, and again I have to substitute z is equal to 1. So the derivative, which is of the form u by v rule. So this is of the form u by v. The derivative of u by v is, so first we have to make v square. So we have to leave as it is. You have to make derivative for u, and again you have to leave u and make a derivative for v. So this is v square by vu dash minus uv dash. So I am doing the same thing and substituting z value as 1. See, this is limit z tends to 1 the derivative. So this is v, so I have to make v square. So this is in the denominator, it is v square, and I am leaving this v, that is z square plus 4, and I have to make a derivative for u, that is 2z plus 2 minus u I am leaving here, that is z square plus 2z, and for v I am making a derivative as 2z. 2z. Now I have to substitute z value is equal to 1. So z square, 1 square is 1 plus 4 into, this is z value is 2. Sorry, z value is 1. So 2 ones are 2 minus, this is 1 plus 2 into, again this value is 2 by z square, that is 1 plus 4 whole square. So this is going to become, this is 5 into 4, that is 20 minus, this is 3 into 2 by 5 square, this value is 25. So which is equal to 20 minus 6 by 25, the value here is 14 by, so this is 14 by 25. So this is the residue value of f of z. This is the residue value, this is the residue value of f of z at point z is equal to 1. So the value here is 14 by 25. See, first of all, what we have done, so the function value here is z square plus 2z by z minus 1 square into z square plus 4. So in order to find the poles, we have to equate the denominator to 0. After equating denominator to 0, so we got the poles as z is equal to 1 is a pole of order 2, and z is equal to minus 2i, and next one z is equal to plus 2a are the simple poles. So we have to find the residues for the pole z is equal to 1, which is of order 2. So this is the formula. In this formula, if I substitute m as 2 and z naught as 1, so after making derivative for one time and substituting z as 1, so I got 14 by 25 is the residue value. And the next one here is the simple pole z is equal to 2i. So for z is equal to 2i, as it's a simple pole, so the formula is also very simple. See, now the residue of f of z, residue of f of z at point z is equal to plus 2i is nothing but c z minus z naught into this one is f of z naught. So this is limit z tends to z naught, z minus z naught into f of z naught. Here z naught value is equal to 2i. This value will be, see here, this will be limit z tends to 2i, z minus 2i into f of z. So this is f of z naught. So f of z can be written as, so f of z value here is nothing but z square plus 2z by, this is z minus 1 square, and this can be written as z plus 2i into, this is z minus 2i. Now I can cancel these two and substitute z as 2i. So this will be, so this will be 2i square plus 2 into, this is 2i by, this is 2i minus 1 whole square into, the z value here is 2i plus 2i. Clear? So this value is nothing but 2 square 4, I square is minus, this is minus 4 plus the value here is 4i by a minus b whole square is nothing but a square. So this is a square plus b square minus 2 into a into b, so 2ab, and this one is nothing but 2i plus 2i is nothing but 4i. Clear? And see here, so if I take 4 as common value, that is 1 plus I. So this value will be minus 1 plus I if I take 4 common, and here this is 4i, and see here this is 2 square, this is 4, and I square, this is minus 1 plus 1 minus 4i. Clear? And if I cancel this 4, this will be minus 1 plus I into I times of, this value is minus 3 minus 4i. So if I rationalize this one with minus 3 plus 4i, minus 3 plus 4i, and see what happens here. Minus 3 plus 4i, then this will become, so if I multiply this is 3, if I multiply this is minus 4i, so if I multiply with the I, this is minus 3i, and this is minus 4 by I times of, see here, this will be a plus b into a minus b, so this value is a square minus this value is b square. Clear? And see, this is minus 1 minus 7i by I times of, this value is nothing but 9 minus 4 square, that is 16, plus a 16. So this is a 16. So if I take minus common here, this will be 1 plus a 7i by this value is 25, and here there is I here. So for minus 1 I'm taking I square. I'm writing this as I square, that is 1 plus a 7i by I into this is 1 is 25. If I cancel I for one time and send I inside, this will be I minus 7 by 25. I minus 7 by 25 is the residue value. If this is the residue value for f of z at point z is equal to 2i. So at point z is equal to 2i, our residue value is nothing but I minus 7 by 25. And the next one here is the residue value for z is equal to minus 2i. For z is equal to minus 2i, see the residue value we have to find out. Residue of f of z, residue of f of z at point z is equal to minus 2i is nothing but, see, first of all I'm writing the formula limit z tends to z naught, z minus z naught into f of z. See, so this is going to become limit z tends to minus 2i, z minus of minus plus 2i into f of z. So what is our f of z value? F of z value is nothing but, this is z square plus 2z by, this is z minus 1 square into z plus 2i into the value here is z minus 2i. So if I cancel this one and substitute minus 2i here, then this will be minus 2i square plus 2 times of minus 2i by, here this is minus 2i minus 1 whole square into this is minus 2i into minus 2i. So this is 4i square. So this value is minus 4. Clear? I square is minus and this value is minus 4i by. So if I expand this one, if I take minus common square, that is a square plus b square plus 2 into a into b. Here this is minus 4i, minus 4i. So this value is minus 4i by, this value is minus 4 plus 1 plus 4i into this is minus 4i. So if I take minus 4 common from this, so this will be 1 plus I. So here this is minus 4i. So this is minus 3 plus 4i. Clear? So if I cancel this minus 4i and if I send I inside, so this will be 1 plus I by minus 3i. This is I squared minus 1. So this value will be minus. This value will be minus. So if I rationalize with minus 3i plus 4, this is minus 3i plus 4. So if I multiply the numerator, then this will be, if I multiply with 1, this will be minus 3i plus 4. So if I multiply with I square, this is minus 1, minus of minus plus 3, and this is again 4i by a square minus b square minus 3i whole square minus this is minus 4 square. 4i minus 3i is nothing but I plus 7 by. So this is 3 square 9 minus 9 and this value is minus 16. So this is nothing but, if I send minus to the numerator, this is I plus 7 by 25. So I plus 7 by 25 is the residue value. So this is the residue value of f of z at point z is equal to minus 2i. So this is how we have to find out, and let me explain you. So first of all, f of z is given as this one. So in order to find the poles, we have to equate the denominator to 0. And after equating denominator to 0, so we got our pole value z is equal to 1, which is of order 2. And z is equal to 2i and minus 2a are the simple poles. So for z is equal to 1, so this is the formula, m is equal to 2 and z naught is equal to 1. And after making one time derivative and substituting z as 1, so we got 14 by 25 is the answer. And the next pole value is, and the next pole value here is 2i. So for the residue value for z is equal to 2i, so this is the formula, that is limit z tends to z naught into only f of z. So this is only f of z, and after cancelling z minus 2 in the numerator as well as denominator and substituting z is equal to 2i, and after calculating we got that is I minus 7 by 25. And the next one here is, so for the residue value z is equal to minus 2i. So again I have to cancel z plus 2i from the numerator as well as denominator and substitute z value as minus 2i, and after calculating we got the residue value for z is equal to minus 2i as minus 1 minus I minus 7 by 25. This is how we have to solve. So hope you guys understand each and every step I have explained. If you really like, and please practice and pass it on to your friends, and thank you for staying till the end.